Hello everybody, welcome to this first session of MongoDB. Now the world is changing. We are also moving from the relational databases to new kind of databases which are available, and MongoDB is one of those very popular databases which is currently available in the market. Today's topic or discussion is all about understanding what MongoDB is all about. So it's more of an introduction to MongoDB while you're making your transition from relational databases to the new databases. I see some of you over here have come for the first time. I doubt many of you may not have in understanding of databases. But MongoDB is for everybody. So even if you're new to handling databases, you're new to handling programming, working with programming languages where you would like to handle data, MongoDB is one good choice that you have, where you will not be bogged down with the complexities that we have to master while we learn databases. It's a very simple way to handle databases or large amount of data. So let's begin with our introduction to this very interesting product, that is MongoDB. Let's understand what it is, what are the features, and what are the limitations, and what are the concerns. So we'll begin with a brief introduction to this very interesting product called as MongoDB. So let's begin with our discussion. Here we go. MongoDB. Now it is an source available cross-platform document-oriented database. Now there is too much that we have written in one line. Source available. Okay, that means you can manipulate the source if you want to. The entire code is available. Cross-platform. That means it can work on Linux, Windows, Mac, any kind of machine. And document-oriented database. Now here lies the major change. Document-oriented database program. So it's a database program, that's understand. But document-oriented. That means unlike in relational databases, we'll no longer have concept of rows and columns. Because since ages, when any record has to be stored, even on a paper, if you have to store a record, how do you go ahead storing a record on a paper? Even in your school days, if the mark sheets were to be stored, or even your report card was given to you, that was more of a table, isn't it? You have unit 1, unit 2, unit 3, unit 4 marks, or subjects on the left hand side and topics on the unit test 1, 2, 3, 4 on the top, and those rows and columns, they create a grid. And the grid, unit test 1 में maths में you secured this much, biology में you secured this much, chemistry you have secured this much. So it has always been a table. Not just in real life when we are not using computers, but even on computers, if I use relational databases, it was more of a two-dimensional table that we have. Story is going to be different now. We'll no longer have this concept of table. Rather, we'll have documents. You can think about the document at times as a separate file or a small piece of code that will store information in a combination of key value. That means for every student's record, I will say, suppose there is a student over here as Ramesh. So I'll say name is Ramesh, okay, and then his age is so and so, his height is so and so, his weight is so and so. I have Gauri, so name is Gauri. So I'll have key as name, value as Gauri. So we'll be storing this as key value combinations in the database. So we have this MongoDB that will store information in document-oriented database. Our tomorrow session will be focusing on this concept of documented-oriented database. What exactly it is, what does it comprise of, how does nesting is allowed of those documents and all things. So tomorrow's entire discussion will be on this concept of document-oriented. But today we are going to have a brief overview as to what it is. First, source available hai, cross-platform hai, that means it can work on different operating systems. Do not have to worry about it. Your code will not change. And document-oriented hai, that means there are no tables. Filal, till the time I do not discuss in detail what document oriented is, that's a topic for tomorrow's discussion. Till that time, understand there are no tables over here. There are no tables over here. It is classified NoSQL database program. MongoDB uses JSON-like documents with optional schemas. Now, when I use the word schema, then that takes you back to object-oriented database, where you have a schema, we have a structure, correct? That's an optional thing. So there is not a compulsion that you have to abide by that particular schema. It's more like JSON. Anybody amongst you, if you have worked with JavaScript object notation, you will find the key value combinations which have been stored. It will be exactly in the same fashion. And when I use the word NoSQL, okay, till the time again don't talk more about it. No longer we will be in a position to use your SQL command. Select star from table, nothing of that sort. So SQL happens to be the standard language for accessing, querying all the relational databases which are there. This is no SQL database program. That means you will not be firing those select statement, delete statement. Oh, that doesn't mean we will not be doing projection or selection or something like that. We can do, but for that you cannot fire SQL statements. So it's no SQL database program. Your Oracle, DB2, PostgreSQL, Ingress, Sybase, all of them are SQL database. Whereas MongoDB is a no SQL database. You will not be firing your SQL statements to get the work done. It was developed by a company called as MongoDB Incorporation and licensed under server side, public license, and so on. Okay, but this company was not called MongoDB always. It was a company called as 10G. MongoDB is powerful, flexible, and scalable general purpose database. Okay, now as I go ahead today, I'll be discussing about this scalability in more detail, because there is where the strength of MongoDB lies. It is very difficult for you to achieve that kind of scalability with ease when it comes to relational databases, and MongoDB scores over relational databases when it comes to scalability. You do not require too much of an expertise to scale up the database. It combines the ability to scale out with features such as secondary indexes, range queries, sorting, aggregation, geospatial indexes, and so on. Today I'll be telling you about all these points. Okay, so it combines the ability to scale out. So what exactly scaling out? What are secondary indexes, range queries, sorting, aggregation and geospatial indexes? That's what I'll be talking about today. But these are some of the advantages which I'll now be discussing in detail as features of MongoDB. We'll be going ahead discussing those things in detail. Now a brief history, like always we do with any technology that we learn. So a brief history of MongoDB as well. So there was a company called as 10Gen software company that actually began developing software. There is MongoDB in way back 2007 as a component of a plant platform as a product. So platform as a service. Now PaaS, platform as a service, PaaS. Now this is a big term nowadays, or very hot kind of term that is there, platform as a service. That means thing is like you can hire that particular service. It's not like you have to purchase it. You can use per use basis also. You can actually pay for that particular service. So you pay as much as you use. So in that particular case, this platform as a service model is becoming very, very popular. Rather, it has been adopted by most of the organizations today. Do go ahead reading about PaaS, platform as a service, PaaS. That's a very common kind of way people now use softwares, platform as a service. Instead of purchasing, we'll pay per use. जितना यूज किया है उतना ही पे करेंगे, and we'll use it as a service. So I'll make a request to you, आप मेरा डेटा स्टोर करो. अगर स्टोर कर रहा हो तो पे करूँगा, नहीं कर रहा हो तो I'll not be paying you. In 2009, now this story started in 2007. In 2009, the company shifted to an open source development model with the company offering commercial support and other services. So what we'll be using is the open source free version. So we'll not have any support from the company because we are not purchasing the license, or rather we are not asking for the support from the company. तो free में support नहीं मिलेगा. Fully functional database is what you will get. Complete MongoDB database you will get, but we will not be getting any support from the organization, from the company, because we are not paying them, isn't it? So as long as we are working in academics and we do not require, our requirements are not that critical, we can do without their support as well. But it is fully functional database that we'll get. It's not like suppose yours is a company and you pay them, then you will get some different version, and if I don't pay them I'll get a different version. No, you will have an opportunity, since you have paid it, you will have an opportunity to customize that database to fulfill your requirement. I will only be using that database if I don't pay. So support will not be available unless you pay. And in 2013, 10Gen changed the name to MongoDB Incorporation. So the story is same like Microsoft or Oracle. The company name was RationalR, but the product became so popular, they changed the company name only to as Oracle. So the company name is Oracle. Actually, Oracle was a product. The same thing with this company as well. This particular MongoDB product became so very popular. The company name was 10Gen, but the product became so popular, the company changed the name to MongoDB Incorporation itself. So the product has become very, very popular in the market. And that's a recent story in 2013. Now we'll start our discussion with various features that are there in MongoDB. What makes MongoDB so very popular today in the industry? So that is what we'll try and understand with the features of MongoDB. You all are here to learn MongoDB. So there must be something exciting about this MongoDB that is making it so very popular today in the market. And it is becoming a database of choice for many developers across the globe which are working on different platforms. We mentioned one term, cross-platform, so it can work on any operating system. That's one of the biggest advantage that we have working with MongoDB. It's a general purpose database. The common kind of requirements that we have, wherein we store the data, we read the data, all the CRUD operations, create, update, modify, delete, all those operations are also available in MongoDB. So it's a general purpose database. So aside from creating, reading, updating, deleting, CURD, create, update, read and delete, these are basic operations. So it will provide you those basic operations as well. It provides most of the features you would expect from a database. So normally in a database management system, you would require ability to store, retrieve, correct, delete, update, all those things are available. Now, there are some additional features that MongoDB provides which sets it apart from the other databases which are there. So what are those features of MongoDB that sets it apart or makes it special as compared to other databases? The first feature that we are looking at is ease of use. You may say, sir, what's the big deal? It is a big deal. Ease of use. It is a document-oriented database, not a relational one. And I told you, in relational databases, we always have the table. There is a schema. There has to be a schema. Schema means a structure. Those who come from C background or programming background, remember you define a structure or a class, then every object of that particular class or a structure would be of the same design. The design is fixed. So schema is fixed. So here in relational database, we have a table and the table structure is fixed. Now once in your school, if the teacher has drawn a table saying the name of the students on the left hand side or the subject names on the top as a column name, the structure is fixed. You cannot add or delete new subjects or something like that. You can at the most add new records. New students is something that you can add. So here the things are actually very different. It's a document oriented database. That means there is no compulsion, although you can use schema. And in real life, we actually use a combination where some partial schemas are always used. Because whatever, there can be some variations that may happen in the database, but there will be some part of the database which is common for all the records. Here in terms of record, we'll say all the documents. So here you have an opportunity to use the schemas partially, or you may not use schema. Point is, that means every record, I'm using the term record because that may sound easy to you to understand what I actually want to say, but here it's not actually record, every document, but you can relate more to records, so I use the word record. The structure of every record can be different. First record can be a movie record, and the second record can be my exam details, and the third record can be my favorite movies. It can be anything. So it's a document oriented database, not a relational one. In relational one, all rows of a table have to have the same structure. In document, that's not the case. Every row may have a different structure. There may be a schema, that's your choice. There may not be a schema. It says, okay, if you want a schema, you can use it. If you don't want to use schema, don't use it. Primary reason for moving off a relational database model is to make scaling out easier. Now this scaling out is something which is very important. Gone are the days, early days when we started using databases, few GB data was thought to be big data. Now when you talk about it, GB is nothing. You have TB, you have PB, you have petabytes of data, and that is coming up, and that volume of data is being generated. So you have to scale up. Now scale up can be done in both the ways, the vertical and horizontal. I'll talk more about this vertical and horizontal scaling as I go ahead. So if you really want to scale up, when the speed with which you would like to retrieve the information is critical, when the volume of the data that you have is very, very large, and then you would like to somehow manage that. So in that case, these document-based structures enable you to scale out very, very easily. Document-oriented databases replace concept of rows with more flexible model, the document. So here we no longer will have rows. In a table, what happens is you have a row, first row, second row, third row, fourth row. And the heading, think about an Excel sheet. how does the Excel sheet appear? In Excel sheet, you have those columns and you can give headings to every column, correct? That's how a database are there in related with DBMS products or related with RDBMS product. We always have this Excel-like sheet, at least logically, where we have those columns. They are headings of the column, like name of the student, roll number of the student, English, Hindi, Marathi, chemistry, physics, maths. Those are the subject headings, and then every row, maybe the first row will have record of Rutuja, second row maybe Sakshi, third row maybe Rohan, fourth maybe Ajinkya. So we will have every row will have the same set of columns, attributes will be the same. Now here we no longer have this concept of rows. Instead of rows, we'll have a document, and it's a JSON like key value combination will store. So it's a JSON document like structure that will have no longer concept of rows. So a table or row दिमाग में निकाल देना है. So even if its record has to be stored, it will be a form of a document. By allowing embedded documents and arrays, the document-oriented approach makes it possible to represent complex hierarchical relationships within a single record. Now, just to give you a brief, tomorrow anyway I'll be talking more about this nested documents and other things, because tomorrow's session is devoted to this document structure only. Now, even before I go ahead discussing more about the document, say I'm storing your details. Say let's say we are storing some students' detail, and we have with us Deepak, and Deepak का details मैं store कर रहा हूँ. Deepak is one entity, correct? But in this one entity called one person called as Deepak, his details I'm storing. I have some personal details about his name, age, date of birth, and other things. In addition to that, I want to store his performance in academics. Now, when I'm trying to store performance in academic performance, then in that case, SEM 1 के subjects, SEM 2 के subjects, SEM 3 के subjects, SEM 4 के subject, अरे all the 4 SEMs that he has appeared so far, या 5 SEMs that he has appeared so far, ये पांचों semester के subjects अलग थे. Number of subjects may also vary. The names of the subject may also vary. That means one document is of the Deepak, or Deepak के अंदर there can be 5 different documents representing his performance in each of that semester. Now that's how the real world is, isn't it? So this complex entity called as Deepak, अगर मुझे मेरे object oriented program में उसे represent करना था, तो Deepak is one person, and this Deepak person has appeared for these many subjects and in these many semesters, and I want to logically represent them. So it becomes like Deepak is one entity with all his personal details, and then his unit 1 semester 1 के subjects और उसका score, semester 2 का subject score उसका score, semester 3 के subjects और उनका score. Point is subject names are also varying and his scores are also varying. So I need to have a document within a document. So it actually helps you to model the real world very well. So when you are trying to, if you are an object-oriented programmer, a C++ or a Java programmer, you'll find this structure very easy when you're trying to read. By allowing embedded documents and arrays, the document-oriented approach makes it possible to represent complex hierarchical relationship within a single record. And that's precisely an example that I gave you. Hierarchical relationship, within one there is another document which is there, and it can be more complex. Currently, the complexity of the thing that I said is not that high. The only thing that was interesting over here in Deepak's example was every semester he's appearing for a different subject. So subject names are also varying, and the scores in the subject name is also varying, and there is this particular person called as Deepak. And then there are personal details, and along with the personal details we also have academic details, and that too academic details for multiple semesters and so on. Now such complex records, if you really have to represent, these document structures become very, very flexible. They are, and point is like now that you also have elective subject. So it can be the case like two students from the same semester may offer different subjects as well, correct? So Rohan and Deepak are in the 5th semester, both are in the same class, but still may offer some different elective subjects. So again the structure is going to change. That kind of flexibility we'll have when we are using this MongoDB. Think about it. All those who have recently finished your relational database discussion, if we really wanted to design such a table where the number of subjects, the names of the subjects will also vary for every student, the nested table also if I try to create, that would also be a challenge, because in a nested table or even nested array if I go in for, how will I identify those column headings and other things? So that is a challenge, and even if I do that, structure will remain same for all the students. Here that's not the requirement. Here the structure can change from one so-called record, it's a document, to another document. The structure can totally change. So it's very, very flexible when you talk about storing the data. So even if you do not have any other database design knowledge, you can still start working with MongoDB and find the flexibility that it provides. I normally, my personal thing, when I teach object-oriented concept in Java or C++, I find it very, very restrictive. But at the same time, when we move to object-oriented concept in Python, it's so very flexible. कहीं भी कोई भी attribute add करो, कोई भी attribute निकाल दो. You can add an attribute to an object rather than adding to the class. It's a new generation requirement where things are not constant. Schemas are changing very often. With every new record, I would like to store different set of data. So that kind of flexibility what Python provides. So if I compare C and Python, likewise I can compare Oracle and MongoDB. So MongoDB is more flexible over here as compared to Oracle or DB2 or any relational product that you talk about. It's more flexible. It will give you opportunity to represent the actual nature of the data what you have inside the database. But the structure, the way the storing is different, but it will allow you to carry out those kind of operations. So complex hierarchical relationship can be represented in a single record, and that too very easily when it comes to MongoDB. Ease of use. Okay. So अगर आपको लगता है ये important point नहीं है, you're mistaken. That's the most important point. There are no predefined schemas. What did I tell you? Schema defines the structure. So if I am talking about normally when I say a record, I know there is a structure. That record will have name, address, phone number, marks, percentage, and so on. अरे but वो fix हो गया. That means with every student you are going to store. I am taking example of students so that you can relate to it. या आधार कार्ड, आपका आधार कार्ड हो, मेरा आधार कार्ड हो, द स्ट्रक्चर इज सेम. मेरा फोटो है, मेरा आधार कार्ड नंबर है, माई एड्रेस इज देयर, माई डेट ऑफ बर्थ इज देयर, दैट्स इट. तो across India and by biometric information that they have captured, the thumb impression, the iris and everything. तो across India, all those billions of people जिनका आधार कार्ड बन चुका है, सबका स्ट्रक्चर एक ही है. दैट मीन्स सेम अमाउंट, सेम सेट ऑफ वैल्यूज हैव बीन कैप्चर्ड. ऐसा नहीं हुआ मेरा एज ले लिया है और आपका हाइट ले लिया है. दैट हैज नॉट हैपेंड. करेक्ट. तो and another piece of advice, don't get carried away with this concept of document. In the real world, normally when you carry out any operations for any enterprise, structure will be fixed to some extent. Here we have a flexibility of changing that structure without doing taking much of effort for a particular record. यानी ज़्यादातर लोगों के यही डिटेल स्टोर किए, बट किसी के हाथ ही नहीं तो क्या करेंगे, तो टो का ले लिया क्या, पैर के टो का इम्प्रेशन लिया क्या. देयर कैन बी सम काइंड ऑफ this is a very weird example, but where the structure changes and you want to store some very different kind of data, that kind of flexibility this will avoid, since there are no predefined schemas. There are no predefined schema doesn't mean you cannot create a schema. You can create a schema. Rather, in the entire course you will find me using some partial schema at least, but that's not a compulsion. You can vary from that schema. There need not be a fixed structure of your database. Compulsion nahi hai. Okay, there are no predefined schemas. Our documents key and value are not fixed, are not of fixed types and size. So it's not like first name है और उसका लेंथ varchar 2 of 30 चाहिए, यानी 30 कैरेक्टर्स ही स्टोर कर पाए, ऐसा कुछ नहीं है. ओके. तो अगर आपने कोई साइज दे दिया फिक्स, नो दैट्स नॉट द थिंग. द टाइप ऑफ द डेटा कैन ऑल्सो चेंज and the size of the data can also change. So all the things can change. The data elements that you are capturing can also change, their type can change, their size can change, everything can change. Rather, you are not specifying only in advance. तो change करने की बात ही नहीं बनती है. But one record to another record, it can change. Without fixed schema, adding and removing fields becomes much more easier. I'm not talking about adding and removing the records. I'm talking about fields. Okay. In the assignment that I had given to you relation DB के बारे में, I said when you make a tweet, some people may retweet, some may not retweet. तो किसी ने मुझे retweet नहीं किया, तो in that case that value will be null. Here retweet नहीं किया तो नहीं, और ट्वीट किया है, मेरा ट्वीट किसी ने रीट्वीट किया है तो वो कैप्चर करना चाहूँगा, 4 लोगों ने रीट्वीट किया तो चारों का डिटेल नाम मैं कैप्चर कर लूँगा, और नहीं किया किसी ने तो छोड़ दूंगा. तो इट इज़ नॉट इवन स्टोरिंग नल वैल्यूज या नल विल की कोई ज़रूरत नहीं है. इफ दैट फील्ड मे बी प्रेजेंट इन वन रिकॉर्ड, मे नॉट बी प्रेजेंट अनदर रिकॉर्ड. That field may be present. Another example I'll take. Suppose there are 2 students. Okay. Anyway, we are going to discuss this in detail tomorrow. There are 2 students. एक अंकित है और एक अनंत है. अनंत और अंकित के मैं पर्सनल डिटेल्स कैप्चर कर रहा हूँ. Anand's father is very strict. He has not given him phone number. Ankit ke dad, he is very friendly. He has given him some phone number. Phone he has given, handed over smartphone. अब जब मैं अंकित का और आनंद के डिटेल स्टोर कर रहा हूँ तो आनंद के फ़ोन नंबर के आगे क्या लिखूंगा? इन रिलेशनल डेटाबेस आई से नल बिकॉज ही डजंट हैव फोन नंबर. और अंकित के इसमें आई विल एक्चुअली पुट द फोन नंबर. करेक्ट. इन MongoDB, if Anand doesn't have phone number, I will not write mention about phone number. Ankit has phone number and he has समथिंग मोर, तो जो कुछ भी है वो उसमें ऐड करूँगा. अंकित के पास आज नहीं है तो नहीं, वेन इन फ्यूचर ही परचेसेस अ फोन नंबर, आई विल ऐड दैट एट्रीब्यूट. And suppose Anant's dad realizes Anant is spending too much of time on phone, so he takes away that phone. So that phone number, not just the phone number, that field phone can also be deleted from Anant's record, not just the value. You may say, sir, we can do it in relational database. मैं उसकी वैल्यू में नल स्टोर करूँगा, अनंत का फ़ोन नंबर अभी कुछ नहीं है. अरे बट फ़ोन नंबर नाम का फील्ड तो है. Here we can add a field, we can remove a field. It's like that information can itself be removed or added. So that's something that we can do with this MongoDB, which is unimaginable when you talk about the other schema type databases that are there. So without field schema, adding and removing fields becomes much more easier. You can add fields, you can remove fields. I'm not talking about records, huh? I'm talking about fields. Generally, this makes development faster and developer can quickly iterate. Now look at this. आज के ज़माने में nothing is fixed. World is changing. आपका कस्टमर मेक्स अ न्यू रिक्वायरमेंट एवरी नाउ एंड देन. बिफोर दैट ही वॉज नॉट कैप्चरिंग दैट इन्फॉर्मेशन ऑफ द कस्टमर. अब उसको कस्टमर की वो भी इन्फॉर्मेशन चाहिए. अर्लियर दे टू कैप्चर ओनली द मेल आईडी एंड द फ़ोन नंबर. अब उसका व्हाट्सअप नंबर भी चाहिए. अब उसका और कोई कोड चाहिए. ओके या आजकल उसका क्यूआर कोड भी चाहिए फॉर ट्रांजैक्शन पेमेंट्स. अब पहले तो क्यूआर कोड नाम की कोई चीज़ नहीं थी. या उसका यूपीआई आईडी भी चाहिए फॉर फाइनेंशियल ट्रांजैक्शन. ओके माई यूपीआई आईडी इज़ लाइक माई नंबर फॉलोड बाय @UPI. दैट्स माई UPI ID. तो आज पहले तो 2 साल पहले ये कॉन्सेप्ट नहीं था. देयर वाज नथिंग एज UPI ID, इजंट इट. बट आज बैंक में UPI ID मस्ट है, ताकि अगर आप एक अकाउंट से एक मोबाइल से दूसरे मोबाइल में फ़ोन पैसे ट्रांसफ़र करना चाहोगे तो आपका जीपे का, फ़ोनपे का या भीम पे का कहीं तो एक UPI ID रहेगा, यूनिक नंबर रहेगा जिसके थ्रू हम लोग उसे आइडेंटिफाई कर पाएंगे. नाउ दैट वाज नॉट देयर अर्लियर. नाउ द क्लाइंट सेज ओके अपने पूरे सिस्टम में एक फील्ड ऐड होना चाहिए. थिंक अबाउट फ्रॉम द रिलेशनल डेवलपर्स परस्पेक्टिव. एक फील्ड ऐड किया तो जो पुराने रिकॉर्ड्स उसमें नल आ जाएगा, जो नए रिकॉर्ड्स आएंगे उनमें वो तो वैल्यू आ जाएगी, और पुराने रिकॉर्ड्स में नल आएगा तो एज एंड व्हेन द पर्सन गिव्स यू दैट इन्फॉर्मेशन को फिल करना होगा. दैट वुड बी क्वाइट अ डिफिकल्ट थिंग टू एक्चुअली इम्प्लीमेंट, नॉट इन MongoDB और इन डॉक्यूमेंट टाइप डेटाबेसेस. अगर किसी के पास है मोबाइल फ़ोन और वो UPI ID है तो ऐड करेंगे, नहीं है तो उसे ब्लैंक छोड़ देंगे. ब्लैंक छोड़ेंगे वो फील्ड ही नहीं रहेगा. सो पॉइंट इज रिक्वायरमेंट्स इन द मार्केट आर नाउ डेज चेंजिंग सो वेरी फास्ट. तो वी वॉन्ट आर डेटाबेस टू अडाप्ट टू द न्यू रिक्वायरमेंट. अब कोई चीज़ की ज़रूरत नहीं तो हटा देना चाहिए, निकल जाना चाहिए. कोई चीज़ चाहिए तो वो फील्ड ऐड करना चाहिए. वी कैन नॉट रिमूव कॉलम्स पार्शियली. दैट मीन्स 100 रिकॉर्ड्स है, उसमें से 10 लोगों के पास फ़ोन नंबर नहीं है तो मैं फ़ोन नंबर निकाल सकता हूँ बट फ़ोन नंबर या कॉलम नहीं निकाल सकता हूँ. इफ़ आई डिलीट द कॉलम सबके फ़ोन नंबर चले जाएंगे. इन सपोज एक्सेल शीट में सबके फ़ोन नंबर आपने रखे, फ़ोन नंबर कॉलम आपने हटा दिया तो सबके फ़ोन नंबर गायब हो गए. उसमें से 5 लोग थे जिनके पास फ़ोन नहीं है तो आप वो कॉलम नहीं हटा सकते, उसको वैल्यू में 0 स्टोर कर सकते हैं या नल कर सकते हैं, समथिंग लाइक दैट. यू कैन नॉट रिमूव दैट कॉलम टोटली ओनली फॉर द स्टूडेंट्स. दैट्स प्रिसाइजली वॉट वी कैन डू. सो इट कैन अडेप्ट टू द न्यू रिक्वायरमेंट्स दैट आर इमर्जिंग इन द मार्केट वेरी वेरी इजीली. तो जो आपके बिजनेस के, सो यू कैन डू मोर इटरेशन. Earlier that was not there in the database. Now the customer wants it, you can immediately add it. उस दिन के आगे तो वो सपोर्ट करना शुरू करेगा. And if you want it to be updated in the previous records, that can also be done. So it makes development faster as developer quickly iterate. तो नया वर्जन डेवलपर को क्रिएट करने में कोई दिक्कत नहीं रहेगी. ही डजंट हैव टू गो बैक, डू सम फंडामेंटल चेंजेस, स्ट्रक्चर को वापस डिफाइन करना है. अरे स्ट्रक्चर ही नहीं है तो डिफाइन क्या करना है. ही कैन जस्ट स्टार्ट यूजिंग इट. सो दैट वाज अबाउट ईज ऑफ यूज. And that makes it as a choice for a lot of developers. But keep in mind, at the end of this, I'm also going to talk about concerns. ये सब कुछ अच्छे चीज़ें भी नहीं है. There are some issues also which are there. Or otherwise, everybody would have switched to MongoDB. ऐसा भी नहीं है. Not everybody is going to MongoDB. अब ऐसा क्यों है? So with every design, there are some advantages, there are pros and there are cons. There are advantages, there are disadvantages. वैसे इसके भी है, इसके भी कोई advantage. Right now we are looking at features. Later I'll talk about limitations and also I'll talk about concerns, जो problems है MongoDB के, that also I'll talk about. So you have to make a intelligent decision. आपके लिए appropriate है या नहीं है, आपको सोचना है. Okay. Scaling. Now this word scaling we came across in the first slide itself. Okay, MongoDB was designed for scaling. It was designed. Rather, need was felt because ये जो आपके सोशल मीडिया वगैरह जो साइट्स है ना, वहाँ देखिए ना डेटा कैसे कैसे आ जाता है. अब हर एक पोस्ट में आप पोस्ट का डेट, टाइम, एवरी टाइम यू मेक अ फेसबुक पोस्ट तो फेसबुक पोस्ट में आपका टेक्स्ट होता है, आपका डेट टाइम किसने पोस्ट किया ये हमेशा रहता है. यस और नो?
यस सर।
ऐसा कैसे? क्या आप फेसबुक में हमेशा टेक्स्ट ही डालते हैं क्या? कभी कभी आपने अपना वीडियो भी डाला होगा विदाउट ए टेक्स्ट, कभी अपना फोटो भी डाला होगा विदाउट ए टेक्स्ट. आपका नेम रहेगा किसने पोस्ट किया है, कब पोस्ट किया है वो रहेगा, सम पार्ट इज फिक्स्ड. बट द कंटेंट, कभी आप फोटो डालोगे, कभी आप वीडियो डालोगे, कभी आप टेक्स्ट डालोगे, समटाइम्स यू मे पुट अक्रॉस सम अदर टाइप ऑफ डेटा. तो पॉइंट इज द डेटा इज चेंजिंग. तो देर इज नो स्ट्रक्चर, सो ये डॉक्यूमेंट स्ट्रक्चर विल बी इंपॉर्टेंट. ये आपको मालूम नहीं है डेटा का टाइप क्या है. पहली बार आपके पास एक वीडियो था तो आपने BLOB लिया था, अगली बार टेक्स्ट आ जाएगा तो क्या BLOB लोगे वहाँ? अगर ओरेकल के साथ मैं कंपेयर करूँ तो बाइनरी लार्ज ऑब्जेक्ट नहीं लोगे. टेक्स्ट के लिए क्या बाइनरी लार्ज ऑब्जेक्ट लेना है, उसके लिए तो सिंपल टेक्स्ट varchar से काम चल सकता था. तो नाउ हियर द टाइप ऑफ द डेटा कैन चेंज, the nature of the size of the data can change, everything can happen. I can have a video which is of 1 minute and another video can be of 1 hour. Size of the data can also change and type of the data can also change. Okay, now the amount of data is also very large. Means Facebook के क्या है, आप और मैं, साक्षी और मैं दो ही पोस्ट डाल रहे हैं क्या? That's not the case. There are millions of posts which are coming. Petabytes of data is being generated every day. अब इस डेटा को मैनेज करना इज़ नेक्स्ट टू इम्पॉसिबल, बिकॉज अगर आप रिलेशनल डेटाबेस में किसी तरीके से इस डेटा को स्टोर भी कर रहे हो तो यू विल हैव टू स्केल इट अप. दैट मीन्स एज द नंबर ऑफ ट्रांजेक्शन गोज ऑन इंक्रीजिंग, एज द नंबर ऑफ रिकॉर्ड्स, सो कॉल्ड रिकॉर्ड्स, जो रिकॉर्ड आपको मालूम है इसलिए मैं टर्म रिकॉर्ड यूज कर रहा हूँ. एज द नंबर ऑफ रिकॉर्ड्स गोज एट इंक्रीजिंग, टू मैनेज दैट रिकॉर्ड्स यू विल हैव टू स्केल अप द डेटाबेस. दैट मीन्स योर डेटाबेस ऐसा होना चाहिए कि वो जो वॉल्यूम ऑफ डेटा बढ़ रहा है उसे मैनेज करने आना चाहिए. इट शुड बी इन अ पोजीशन टू हैंडल दैट वॉल्यूम ऑफ डेटा दैट इज बीइंग जनरेटेड. So if the volume of data that is being generated is large, you have to scale up. So what do you mean? There are two ways to scale up a database. The first is vertical scaling. Now what do you do in vertical scaling? Increase the CPU or RAM of existing database machines. तो एक है RAM और CPU आप increase कीजिएगा. Processing power if I improve. The RAM, the amount of memory that is available that I improve. So what will happen? You can have more data in the cache. Cache में if there is a data, you can access it faster and you have a better CPU. You have more CPUs. You have more processing power. The processing can be done faster. And when the volume of the data increases, tomorrow, as I go ahead, I'm going to give you some statistics also. And especially regarding the relational databases. If there are 1,000 records, if there are 1 million records, if there are 100 million records, how much time it can take to retrieve some piece of information. And think about Aadhaar database where there is 100 million records which are there. Of 100 million, from the 100 million record you have to fetch somebody's details. I have Aman, and Aman ka detail from 100 million records I have to search. Aman ka phone number from 100 million records. Now that's gonna be a challenge. लकीली उसका नाम ए से स्टार्ट हो रहा है तो शायद ए से इंडेक्स है तो जल्दी मिल जाएगा. बट कोई हमारे पास जहीर है, जहीर का तो कहीं दूर रहेगा तो इट विल टेक मोर अमाउंट ऑफ टाइम फॉर यू टू. बट देन इफ़ यू हैव बेटर CPU, इफ़ यू हैव बेटर RAM, तो मोर अमाउंट ऑफ डेटा कैन बी पुट इन टू कैशे एंड इन मेमोरी ऑपरेशन कैन बी डन वेरी वेरी फास्ट. बट देन हाउ मच ऑफ मोर हार्डवेयर यू गोना पुट, आप कितने CPUs ऐड करोगे, आप कितने CPU मीन्स how much more processing power will increase, how much of more RAM that will increase. Now that is a limitation. So that's vertical scaling where we increase the processing power and we increase the amount of RAM that is available for your database machine. यानी आपके database में RAM और processor हम बढ़ाते जाएंगे so that it can work faster. Vertical scaling. And second type of scaling is called as horizontal scaling. By adding additional machines to your database cluster, each which handles a subset of the total data. Because vertical scaling का limit रहेगा. How much of RAM can you install? अगर आपके यहाँ 2 slots है या 4 slots है, that's it. तो हर एक slot में maximum जो RAM का size मिलेगा, that you will put. You cannot add more slots on your motherboard. Not possible. How many CPUs will you increase? That depends the kind of server that we have. There will always be a limit as to how many CPUs we can increase and what kind of CPU will be supported by a motherboard. So there will always be a limit that we can have. Now the only problem, the way vertical scaling problem can be addressed is horizontal scaling. We had a very powerful server. There were 10 CPUs and 100 GB RAM. Okay, fine. But that was a limit. Now you cannot go beyond that. Then what I'll do? I'll take 4 such servers. I'll take 10 such servers. I'll take 100 such servers. Okay. And now why are we taking these additional servers? Here, I would also increase the amount of data that is there, which I'm going to store across those. We call them as, I'll come to it. We'll create a subset. Okay, we'll create a subset. That means a large amount of data I will divide into parts and I'll divide it and store it into the database cluster on each of the machines. Some part on one machine, some part on other machine, some part on other machine, some part on other machine. Do you see the problem with this? What may happen? Yes.
सर अगर लास्ट डेटा मतलब डेटा अगर लास्ट क्लस्टर में स्टोर है तो सब में कंपेयर करके जाना पड़ेगा.
आप में एसक्यूएल की दैट्स वेरी ट्रू बट इफ यू लुक एट एवरी एसक्यूएल स्टेटमेंट दैट वी फायर इट डज अ स्कैन फॉर द एंटायर टेबल. If I say select
Yes,
star
sir.
from student where roll number where percentage marks greater than 70, do you know percentage marks greater than 70 पहला रिकॉर्ड रहेगा या आखिरी रिकॉर्ड रहेगा या बीच में रहेगा. तो you will have to scan the entire table. Now if you have to scan this entire table and if the data is stored across 4 different or 5 different machines servers, then what will happen is your query that you have fired will internally give a network call that will first check on the first machine, then a network protocol that will take your control to the next machine, then the next machine, then next machine, and then get that data and then give you the final result. Now that's going to hamper the performance significantly. So by adding machines to your database cluster, each which handles a subset of the total data. Some part of the data is one machine, some part of the data is another machine, some part of the data is another machine. You may have created a cluster of machines, but still it has its own limitation. One problem that you have handled is now if the data increases, I'll add one more server. If data increases, I'll add one more server. So you can now store more amount of data because you have several machines which are added to your server. So एक है vertical scaling wherein we'll improve the power, the memory and the processing power of a server. Second is horizontal scaling where we'll add the additional machines only to the cluster. So that entire cluster is and the data is stored across the entire cluster, not just in one machine. MongoDB was designed to address to this particular problem. It was designed to scale out. The very idea, philosophy, why we need to have such kind of database was to address to this major concern. So one big concern that MongoDB very nicely addresses is this scalability. So it was designed to scale up. Document-oriented data model makes it easy to split data across multiple servers. So there is no schema, there is no relation that I have to maintain. It is actually, we'll be learning this concept. It is very easy to split your data across different machines, servers. It automatically takes care of balancing the data and the load across a cluster, redistributing documents automatically and routing reads and write to the correct machine. Okay, so there are number of documents. Here we have documents. Each document is like one record. So there are millions of documents which are there. So it will now distribute that thing properly onto different machines. And when you are trying to fetch some, carry out some kind of operation, it will the reads and write that you are doing. Normally it will be more of the time it will be read operation that we do. So it will route the data from the correct machine, get the data from the correct machine, and give it in the final result. Now these operations, because of this flexible design of documents, can happen very fast as compared to your databases. So what exactly is this term of cluster that we have been using? Because we have mentioned this term of cluster of machines. So what is this cluster? In context of MongoDB, a cluster is a word that is usually used for either a replica set or the shared cluster. Now what is this replica set and what is this shared cluster? Okay, so let's understand these two terms, very important terms, a replica set and shared cluster, and you will understand the significance of both of them. First, replica set. Now data is so critical. If data is lost, everything is lost, isn't it? The companies will wind up, if suppose Facebook loses all the data tomorrow, something happens, their server crashes and data is lost, Facebook has no value, correct? It has no value, it's gone. Bank, SBI bank loses all the data, सब machines वगैरह intact है sir, कोई problem नहीं, there is no problem with the machine, the data is gone. Now that's a problematic thing. Okay, so एक machine crash हो गया तो, server crash हो गया तो, so what they do, they use this concept of replica set. A replica set is a replication of group of MongoDB servers that hold copies of the same data. That means if there are some critical data that are stored, and to take as a safety measure, you will have a exact replica of the data on another machine. So if suppose one machine was in Pune, another machine was in Uttaranchal, and Uttaranchal is like seismic zone, there is more chances of what do you say, more chances of earthquake, and वो तो आ गया और अपनी बिल्डिंग जिसमें वो सर्वर था वही क्रैश हो गया. But at the real time, I'll have a backup in Pune. Pune happens to be on the Deccan Plateau, where except for once there has not been in the last 200-300 years, there has not been any major earthquake except for Killari earthquake that happened. Maybe I was in school days. That was the only time, which was a surprise thing for everybody because this Deccan Plateau is of hard basalt rock. तो यहाँ earthquake का कोई chance नहीं था, फिर भी exceptionally हो चुका है. But otherwise, there are no earthquakes that happens in the Deccan Plateau. So it could be best if you keep your server in Hyderabad, Bangalore, Pune, safest places, because there are no chances of earthquake. But then If something else happens, the building collapses, oh then the data is lost. Earthquake तो नहीं हुआ, but building ऐसे एक terrorist इसमें या fire में गया, so we need to have real time replica of that particular machine. So that's a replica set. So replica set is a replication of group of MongoDB servers that hold copies of the same data. This is fundamental property for production deployment as it ensures high availability and redundancy. One machine goes down, my system will not stop because I have another machine on which the same data is available, and which are crucial features to have in place in case of failures and planned maintenance period. Now, चलो ये earthquake वगैरह कुछ नहीं हुआ है, आपको कभी तो at some day, some places you will have to have done the maintenance of your machine. कभी तो you will have to blow the machine if there is a dust. Now these are dust-free environments, but you will have to do some maintenance of your machine. You have to upgrade the machine, something like that. So if you're going to turn off your machine, do you mean all the applications should also get turned off? That's not very good, na? Once in a while, once in 4 years, 2 years, you can do that. And sometimes banks also tell you there is a scheduled maintenance. You must be getting a message: scheduled maintenance at right 11 o'clock to morning 5 o'clock, and the banking service will not be available. But does it happen every day? No, that's something which happens very rarely. But then daytime, if there is something goes wrong, some machine fails, my applications that are working on that particular database should not fail. So the routing should be done to the correct machine. That means there is a replica which is available. So if Pune machine fails, the same data is available in Bangalore server, so it should now continue with the Bangalore server as well. Okay, so there are replica sets that are being created. Replication of group of MongoDB servers. So you will have servers and you will have copies of that servers, and you have multiple copies of that server. And why do you want to have this? Because we have to manage the failures. Okay, we have to manage the failure. Downtime होना ही नहीं चाहिए. If one location is down, same data is available from other location, and from where the applications will continue to run, because all your applications are based on the database. So cluster, we said in two terms we are going to use this concept of cluster. क्या? एक है replica set और दूसरा है shared cluster. अब ये shared cluster क्या है? It's also commonly known as horizontal scaling, where data is distributed across many servers. It's not replicated now, distributed. Okay, the first was replica set. This is shared cluster, where data is not replicated but distributed. Means the data is so very large it cannot fit onto one server. So one part on one server number 1, another part on server number 2, और ये server 1 और 2 का एक replica रहेगा. So I have a group of servers where the data is scaled horizontally. That means you have divided it across multiple databases, and I have a cluster, a replica set of that set of servers as well. Okay, so shared clusters and replica set is what we are doing. Here what we are achieving is horizontal scaling. That means I will have similar power machine, one more machine, one more machine, one more machine, multiple machines, or I can have multiple machines with different power as well, and I'll distribute my data or the documents across those machines. The main purpose of shared MongoDB is to scale read and write along multiple shades. Now the basic idea over here is like you can have multiple application drivers. There can be one Java application, there can be one Python application, there can be one JavaScript application which is there, and your data is stored across different machines, the first shared, the second shared, and so on. And you have this Mongo's router that will route your request to the correct server where that required data is there, and it will fetch the data and give it to your application. I'll talk more tomorrow about this application drivers as well, but I mentioned something. You may have the first application in Python, second in C++, and third in Java. That's okay. MongoDB will provide you support for all of them. All these three applications, which are written in different technologies, may be expecting data which is stored across different machine. एक shared machine 1 है और दूसरा machine 2 है. And you as an application developer, if you are a Java developer or Python developer or C++ developer, you do not have to worry about ये नीचे whether it's shared or horizontal scaling has been done and it has been stored, distributed across different machines. You don't have to bother. You are going to make your request to this Mongo's router. You make the request to the Mongo's router, that will route your request to the right machine where the data is stored. So it will have information कि where is this data set stored. आपका डेटा सेट कहाँ स्टोर है, you will have that information. It will route your request to that shared data. You want to read or write operation you want to perform on that machine, you can perform. All that configuration will be done where what is stored. This Mongo's router will read from the configuration. Say application 1, 2 and 3 है. Application का data was on the first machine, application 2 and 3 का data was on the second machine. What they were using, some part of the data. So this router will correctly route that information, the request for read and write operation to the correct machine. So that's something that can happen. So even if it's distributed, the configuration server will keep in records about how the data has now been distributed. So when the request comes from the application developer, it will correctly be forwarded to that particular physical machine. For you, the database is the same, but the physical machine which is storing that part of the data, the routing will happen transparently. You will not even know. So you and me as a Python, MongoDB developer or a application developer, Python, Java, C++, whatever it is, we are not really concerned what that administrator has done. We'll just make a request to this Mongo's router, and the data will be either read or write, whatever you would like to do. All those operations will happen seamlessly for you in the background. Another very important property over here is that of indexing. Now, a secondary indexing, we also have that in your traditional databases. Now, something more. You have this secondary indexing. Then what is primary indexing? Say you have details about a bank. Bank, there are millions of customers which are there, and every customer has a bank account number. So bank account is a primary key. There are no two customers having the same bank account number in entire bank. In SBI, there will not be any two customers, father and son, husband and wife. They will also not have the same number unless it's a joint account. But then for the joint account, the number will be unique, and for the personal account, the number will be unique. So if I talk about an index, you can think about those who are new to DBMS. You can think about index as what we have content on your first page in a textbook. So you have chapter number 1, the page number, chapter number 2, the page number, and at the last you also have an index where it says, oh, topic of MongoDB is there on this page. So you directly jump to that particular page. If I give you a 1000 pages book and I ask you, go to chapter number 14. Now, how will you find out if there is no index chapter number 14? You have to go through one page, and it was on 800 page. So unless until you have scrolled 800 pages, you will not even know whether chapter 14 has started or not. Now that could be quite a tedious work to do. But if you had an index, I can just see, oh, chapter number 14 is on line number 800, page number 400. I can directly jump to page number 400. Faster retrieval is a basic objective of indexing. If you are done indexing, you can retrieve the data within no period time. Faster retrieval can happen. But when it comes to indexing, almost all databases, NoSQL ho ya koi bhi database ho, they normally create your index, relation database, they normally create your index on the primary key, which is unique. But sometimes you are fetching information. Suppose I have, mine is like company like Tata's, and Tata has lakhs of employees, and they want to know every employee will have an employer ID. Every employee will have an employee ID. Now that's a primary key. That is never the same for two employees in Tata's. Every employee has a primary key, or every student in University of Pune has that permanent registration number. And that is never the case. My permanent registration number in Pune is not same as any of you who is attending the session today. Correct? So that's a unique number. But then University of Pune fails. We would like to know all details of all the students who are staying in Pune. When they are registered, they were staying in Pune. Now based on that, now they want to search on name. No, search on the city name and not on the permanent registration number. So now that's a secondary key on which index should have been there. If there was an index which was created on city name, so in that case the search would have been very fast. So you can have multiple such secondary indexes which are there depending on what are the columns or attributes based on which properties, based on which you are doing constant search. I want to know as a banker, which are the customers whose bank balance is more than 10 lakhs? Oh, they are high value customer for me. So I want to have one more index based on the balance in the account as well. So I'll quickly have all those people who have 10 lakh income, 50 lakh income balance, and so on. So it provides support for generic secondary index. So we call them a secondary. Primary is on the unique key. Secondary can be on a duplicate key as well. And provide unique, compound, geospatial and full text indexing capability as well. Okay, full text indexing capability doesn't, okay, but the geospatial is also something very important. Now compound means more than one column ko join karke you can create an index. I want those females from Pune. Now index is on two things, gender and city is Pune. तो और city based भी चाहिए. तो city and gender both combination चाहिए था. और permanent registration number for those students who have passed out in some year. So year and the permanent registration number, दोनों का combination. So you can have compound indexes as well. And geospatial. That means if there is anything in space, it will have some coordinates through which you can identify any item which is there in the space. It can be you sitting at your in your house. That will also have some coordinates, correct? Latitude, longitude kind of thing. Or there is one point on a surface that will also have a position. So geospatial data will help you to identify anything in the space. It can be there is a sphere, and on the sphere there is a point. So I want to find out where exactly on the sphere that point lies. Okay, so it's the earth, and where exactly on the earth you are there. So it can be any on anything where that particular thing lies. So in the, what did I say, in the space where that particular thing is existing, you can actually create indexes based on the geospatial data as well. The simplest thing is like you send your location, na? So your location data can be one geospatial data that is there, and for that location that is unique, na? But you can create index based on the geospatial data. So all of you send me your current location, and then I'll find out who are the people who are within 2 kilometers from my place, correct? So I can come down and visit for a cup of tea. Okay, so geospatial data, and that will have different things. It will have the latitude and longitude based on that. So I can create indexes on that geospatial data as well when it comes to MongoDB. Second index on hierarchical structure such as nested documents and arrays are also supported to enable developers to take full advantage of ability to model in a way that best suited for the application. Think about Deepak ka example जो मैंने लिया था, Deepak and Rohan. I said Deepak and Rohan are 2 students from 5th semester from University of Pune, computer science, and then and likewise there are another 100 students in their class, and then there are thousands of students in entire University of Pune who are appearing for 5th semester. Now amongst them I wanted to find out those students who are from the 5th semester and who have opted for a particular subject as honors subject that you have, one elective subject जो आपने लिया है. किसी केस में वो सब्जेक्ट ही नहीं रहेगा या वो एट्रीब्यूट ही नहीं रहेगा, वो जिसमें है मुझे ढूंढना है. And that too it can be within the nested document. Document के अंदर document है. One is the document that is the record of the person. Within that there is a document which talks about the semester number 5, और semester number 5 के अंदर there is this subjects that you have. I can actually create second index on the hierarchical structures. Nested documents पे भी मैं second index create कर सकता हूँ. So that's something which is very important. Another important feature is that of aggregation. Now this can be a completely new term for us. Let's understand what exactly do you mean by aggregation. What is this aggregation? It provides an aggregation framework based on concept of data processing pipeline. Those who have done functional programming with me, you can immediately relate to what it is, as I show you an example. Okay, we say something as a stream, dot filter, dot map reduce kind of thing that we have done. We have done in C++, we have done it in Java as well. But then what is happening over there? You have one set of data on which you carry out a filter. So filtering is done, and after filtering you do, after filtering means some condition, you would like to sort out only those people who have scored more than 70%. तो एक filter कर लिया, तो filter होके वही students आएंगे जिन्होंने less than या greater than 70% score किया हुआ है. अब वो जो data है, on that I'll add another processing I'll do. I would like to have the totals of all the subjects. Okay, या highest marks in any subject. The highest mark का subject मैं ढूंढना चाहूँगा. Highest mark का subject I would like to find out. So one after another, at every stage, we'll carry out some kind of processing and we'll get some data that will be forwarded to another processing. So I'm going to create a pipeline, and I'm assured that as I go through that particular pipeline, my required results will be arrived at. Aggregation pipeline allows you to build complex analytical engine by processing data through series of relative simple stages on server side. तो विल हैव सिंपल स्टेजेस ऑन सर्वर साइड. फर्स्ट फिल्टर रहेगा, एक रिड्यूस रहेगा, ऐसे अलग अलग स्टेजेस फाइंड करेंगे और डेटा हर एक पाइपलाइन क्रिएट करेंगे और पाइपलाइन के थ्रू डेटा पास होते रहेगा. एट एवरी स्टेज देयर इज सम ऑपरेशन दैट विल हैपन एंड द डेटा विल गो ऑफ. एवरी स्टेज सम ऑपरेशन हैपन एंड द डेटा विल गो ऑफ. So it allows you to build a complex analytical engine by processing data through series of relative simple stages. यानी फर्स्ट स्टेज पे ये ऑपरेट हुआ, देन द डेटा कम्स आउट, देन सेकंड स्टेज पे ये ऑपरेशन, एंड लाइकवाइज यू कैन हैव दिस सीरीज ऑफ स्टेजेस एंड you can do a lot of database optimization also here. So MongoDB aggregation pipeline consists of stages. तो यहाँ अलग अलग स्टेज है. Each stage transforms the document as they pass through the pipeline. So it will carry out some kind of transformation in the document as the data goes through that particular pipeline. So you had a huge data that goes into the pipeline. At every stage there is some changes that happen. Then next stage, and then you will get the required result that you would like to have. Pipeline stage do not need to produce one output document for every input document. For example, some stage may generate new document or a filter out documents as well. It is not like whatever document that we send, that itself has to get changed. That can be the case. Or you send one document and you get another document, and that another document is sent on a stage, you get another document, and through that pipeline those new documents will go ahead flowing, and at the end you will get what you really wanted to have. So to put it across in a diagram, you have some input document and you are doing some filter, some match condition you are doing, and then you are doing some grouping, and after grouping you are doing some sorting. So it could be like same data is being transformed to get the output, or after matching you get a new document, उस पर grouping कर लिया, that gives you a new document जिस पे sorting कर लिया, and that you can give you the final result. So that's how you can establish a pipeline. You can establish a pipeline and then you just send the data to that pipeline. आपको जो changes करने चाहिए थे आपको वो होके at the end you will get your final result. And it becomes so very easy to even think about it, and writing this script is also very easy, because we will create this pipeline and just send the data to that pipeline. All the transformation will happen. It's more like writing an application wherein you take the data, carry out operation, then send, call another function, then call another function. Here it can be done. जो visually दिखाई दे रहा है आपको अभी, the picture that you get, image that you get to see, exactly in the same fashion we can write in the program as well. So that's the beauty of aggregation pipelines which are present in MongoDB. Aggregation pipeline is a framework for data aggregation model on a concept of data processing pipeline. ये data processing pipeline का example दिया मैंने. Documents enter multi-stage pipeline that transform the document into aggregated result. So it will just keep on transforming, and you will get the final result that you like to have. So that was about aggregation pipeline. Now, there is something special collections index types. Okay, what are the special collection? Now something very interesting. TTL, time to leave collection. Now as the name says, time to leave, LEAVE वाला नहीं है, LIV वाला leave है. Time to leave collection. Now what do you mean by this time to leave collection? Suppose now आज का session चालू है, and how many students have attended this session? I want to know, have this information for a particular point of time during the session. Later I don't want that information to be stored, so it should get destroyed automatically. That means you can specify the amount of time for which that information should be retained. Now here there are two things that we can do. I'll be giving you example of this when we implement MongoDB. Time to leave, TTL collection. Collection is a data that should expire at a certain time, such as session or fixed size capped collection for holding recent data such as log. एक capped collection भी है और एक time भी है. That means I have specified the size. If it goes beyond 1 GB, destroy करो, फिर से नए से write करो. Capped data, fixed size capped data. That means the size of my data file document will not go beyond, suppose मैंने सोचा 10 MB का डेटा चाहिए, 10 MB के ऊपर जाता है तो डिस्ट्रॉय करो, स्टार्ट फ्रॉम जीरो फ्रेश. That means when it crosses 10 GB MB, I do not want to store that data anymore. So if that is your requirement, वो हो गया fixed size collection. दूसरा है should expire at a certain time. Now the time can be, you can say today evening 5 o'clock तक वो डेटा रहना चाहिए, 5 बजे वो डेटा एक्सपायर हो जाना चाहिए. Expire means it should get lost. Yeah, after every 1 hour the data should expire. That's what we can do. You do not want to keep a log. Log is like a record about what happened in your databases. I do not want to hold on to the log for a very long time. That log should get destroyed after 1 month, after 1 year. You can specify the date and time when it should get expired. So time to leave. So how long that information should live in your memory, in your means आपके application के database के. That is something that we can specify. So how long that information will live in the memory can be specified. Moment the time interval is over, gone. Moment the size is limit is reached, gone. And then we can also do something that we had seen in log files in Java कि I'll have rotating log files, 5 files cover हो गए तो पहला फाइल overwrite किया जाएगा. Something like this can also be achieved over here. It also supports partial indexes limited only to those documents matching a criteria filter in order to increase efficiency and reduce amount of storage space required. क्या कहता है? Partial indexes limited only to those documents matching a criteria filter. That means I do not want to create a index which is for the whole data. Remember when we had created indexes in RDBMS, when I say create index name, that was for all the records. Done. It was not like only to those records which are matching this condition उन्हीं के लिए index create करो. No, it was for the entire record, all the rows. तो complete scan of your table has to be done. Here we can create a partial index. I want to have index of index based on the permanent registration number, but for only those students who are from Pune, because यूनिवर्सिटी ऑफ पुणे में 3 डिस्ट्रिक्ट्स आते हैं, पुणे, नासिक एंड अहमदनगर. तो आई वांट टू हैव एन इंडेक्स ओनली फॉर पुणे सिटी, करेक्ट, for those students who are in Pune city, but all the everybody is a student. So I want to create a partial index. So I have a data of 3 districts, but out of which I would like to have an index created only on Pune, because my search are commonly on Pune. So then why have, and I'm not going to create a compound index. So don't think about I'll create an index based on एक दिमाग में आएगा आपके, इंडेक्स क्रिएट करेंगे कंपाउंड इंडेक्स बेस्ड ऑन PNR नंबर एंड द सिटी नेम. अरे मगर वो औरंगाबाद के बच्चों का भी, अहमदनगर के बच्चों का भी इंडेक्स हो जाएगा, एंड नासिक के बच्चों का भी इंडेक्स हो जाएगा. आई डोंट वांट दैट थिंग टू हैपन. I want a partial index limited only to students from Pune, not from Ahmednagar, not from Nasik. Such partial indexes can be created over here, and that's a special thing, isn't it? Because when you work with DBMS, we create index, it's created for the entire table. Or otherwise, you create a view, and on that view you create an index. That means additional memory is to be allocated. So you can save on memory. Another very important thing is file storage. Now when you talk about file storage, you'll be surprised to see here there is a limit as to how big a document size can grow. It cannot go beyond something called as 16 MB. So whatever file size that you can store, 16 MB, and we are talking about data is huge. 16 MB is nothing, isn't it? 16 MB is nothing. Oh, that's the size of one BSON document. What is that BSON? We know JSON. So ये BSON क्या है? I'll explain it tomorrow. It's a binary format of that JSON data that is there. तो ये जो डॉक्यूमेंट है, एक डॉक्यूमेंट का लिमिट है इन MongoDB, लाइक 16 MB के ऊपर एक डॉक्यूमेंट नहीं जा सकता है. देन हाउ डू आई हैंडल मिलियंस ऑफ रिकॉर्ड्स, मिलियंस ऑफ डॉक्यूमेंट्स? ओके, नाउ यू हैव दिस GridFS. इट्स अ स्पेसिफिकेशन फॉर स्टोरिंग एंड रिट्रीविंग फाइल्स दैट एक्सीड दिस BSON document size of 16 MB. So you want to go beyond 16 MB, you have this opportunity that is there. Instead of storing a file in a single document, GridFS divides the file into parts or chunks and stores each chunk as a separate document. Done. And how many chunks you can have? You can have as many as you want to, the way you configure. So there is, logically speaking, there is no limit now. You can create as many chunks as you want, but no chunk will be more than 16 MB that you can do. By default, GFS uses default chunk size of 255 KB. That is, GridFS divides a file into chunk of 255 KB with an exception of the last chunk. ये last chunk का exception क्यों है? अगर 255 KB का एक chunk मैंने create किया और मेरा suppose 255 in plus 255 that becomes 510, but मेरा data 550 bytes का है, kilobytes का है. Then what will happen? तो 550 किलोबाइट्स को दो चंक्स में डिवाइड करोगे, तो पहला चंक 255 किलोबाइट का, सेकंड चंक ऑफ 255 किलोबाइट्स, बचे 40 किलोबाइट्स. तो 40 किलोबाइट्स इज द थर्ड चंक. तो लास्ट चंक में ऑफ डिफरेंट साइज, द अदर चंक्स विल बी ऑफ फिक्स साइज. नाउ another feature, ad hoc queries. Ad hoc, that means something which is not very common. It supports field, range queries and regular expression searches. Range queries. Now when I use the word range, that means that query should be applicable only on part of the subset of the data, not the entire data. Range queries. Okay. Then regular expression search. Regular expressions, like those are from programming, you already know what regular expressions are. You can give a pattern. I would like to know names of all the students whose names ends with A या starts with A. Correct? ऐसा कुछ, या ऑल दोज पीपल हु आर फ्रॉम जिनके सिटी का नाम P से स्टार्ट होता है. वो पटना भी हो सकता है, वो पुणे भी हो सकता है, वो पुडुचेरी भी हो सकता है. तो आई एम डूइंग सम रेगुलर एक्सप्रेशंस. करेक्ट. सो और ऑल द स्टूडेंट्स जिनका नाम है ना विच साउंड्स लाइक अमन, साउंड्स लाइक चित्रा. तो स्पेलिंग कैन बी रॉन्ग, डिफरेंट, बट समथिंग लाइक दैट. सो आई कैन क्रिएट CHI तो है नाम में और लास्ट में A है, तो ऑल दोज नेम्स वहाँ जाए CHI और A रहेगा. रेगुलर एक्सप्रेशन, नॉट द साउंड्स लाइक, बट रेगुलर एक्सप्रेशन आई कैन अप्लाई. आई कैन गिव सम वाइल्ड कैरेक्टर्स, पैटर्न मैचिंग, दोज थिंग्स कैन बी डन इन द क्वेरीज. यू से सर वी कुड हैव यूज्ड रेगुलर एक्सप्रेशन इवन इन RDBMS. तो उसमें क्या है? आई एम नॉट सेइंग दिस डज समथिंग विच दिस इज डूइंग एवरीथिंग दैट RDBMS does, or this does something that RDBMS cannot do. I am not saying that. What is available over here is what I am specifying. Partial indexes is a special case. Okay, range queries, special case. Regular expressions today are supported by almost all the databases. Here there is important. Your queries that you are firing to return a specific field of document can include JavaScript functions. That means your data is going to be processed by a function. In SQL, if you are working, most of the time you will be calling only SQL functions. That will carry out some processing of the data as a where condition, where you can say where something, some function name, and that function gives you a result. But that has to be an SQL function. Here, it can even be a function written in JavaScript or some other language. So your query can include functions which you have written in JavaScript. So that can also be a part of my query. That's something which is exciting. And it can be in any language, but JavaScript happens to be the default one. Queries can also be configured to return a random sample of result of a given size and so on. So these are something extraordinary features that we have. Then, programming language accessibility, another very important thing. Now, MongoDB is a database. Oracle is a database. DB2 is a database. Now, if I have to access DB2, if I have to access Oracle database, I need to have only one language, that is SQL. Is there any other language through which you can access the DBMS products, RDBMS products? Yes or no?
Only SQL, sir.
Only SQL. That is the standard language for all relational databases which are there. That is not the case when it comes to MongoDB. You can have drivers, and that will enable you to access MongoDB data through any language of your choice. And there is where you are going to tell me, because I have left out in the implementation some aspects, because you will at the end of the day will have to tell me through which language you would like to give me a demonstration. Okay, because we have a choice of languages that are there. MongoDB has official driver for all major programming language and development environment. C, C++, Java, Python, Ruby, सबके लिए there are built-in drivers which are available. You can interact with the database directly. There are also large number of unofficial or community support drivers for other programming languages and framework. I will not be talking about those non-standard. I will only focus on those standards which are there. Okay, so if you just want to have a list of the drivers which are there, I'll just show you a list of drivers that is there, the language. Anyway, we will be doing installation. तो आई एम जस्ट वंडरिंग, कल डॉक्यूमेंट का एग्जांपल लेते हैं और परसों इंस्टॉलेशन लेते हैं, या पहले इंस्टॉलेशन लेते हैं फिर डॉक्यूमेंट का एग्जांपल लेते हैं, समथिंग लाइक दैट वी डू. तो सपोज if you look at drivers, look at these drivers that are there. Almost all popular languages. Okay, तो इनके अलावा आप क्या यूज करोगे? या C या C++.
Sir, share your screen.
Not visible.
Screen नहीं share किया. Look at this. You have support for almost all languages. आपके पास ड्राइवर्स है, एग्जिस्टिंग ड्राइवर्स फॉर ऑलमोस्ट ऑल लैंग्वेजेस. यू मे बी कंफर्टेबल विच योर लैंग्वेज. सी में आप इंटरेस्टेड हो, C++ में C#, Node.js, Java, Go, PHP, Python, Ruby, Swift, Scala, Rust. Now this comes from the MongoDB itself. But then if you want to have some language that you are using, which is not listed over here, you can go in for a community support libraries as well, third party. But this comes from the house of MongoDB itself. And these are all the common languages that we use, isn't it? Java है, Python है, C++ है. So these three will cover chunk of the languages. Yeah, these four will C++, Java, Python will cover the major work for you. And Microsoft में C# है. तो हर लैंग्वेज के लिए आपके पास ड्राइवर अवेलेबल है. तो यू कैन गो टू द ड्राइवर, यू कैन इंस्टॉल दैट पर्टिकुलर ड्राइवर, एंड यू कैन स्टार्ट यूजिंग दैट ड्राइवर. PHP or other languages are something that we use. So we have drivers for all the languages. So it becomes very easy for you to access your database through whichever language that is of your interest. Yeah, in whichever language you have built your application. So you don't really have to worry or learn new language. So if you are working on a RDBMS product, you'll have to learn SQL. Here you can just continue with your own language. So all things are available, and serverless access. So this MongoDB Stitch, okay, that provides serverless access to MongoDB and other services. Client libraries are available for JavaScript, iOS, Android, and so on. So it becomes all the more easy. Installation of things are no issues at all. You can have serverless access to the database and so on. Then there are some limitations as well. That is something that you should keep in mind. Limitations and concerns, दोनों चीज़ों को याद रखना है. अब इसके limitations क्या है? Some features common to relational databases are not present in MongoDB. Notably, complex join. Now let me add a rider over here. This presentation maybe I have to update. I think till version 3.2 this was an issue here. In the newer version they have now increased the ability to create a bit more complex joins even in MongoDB. To some level more feature has been provided, some ability has been provided, but then not comparable to relational databases, the kind of complex joins that we can create. Joins means there are two different databases and we would like to join them together to get some data out of it, employee and departments, and I wanted to get some data from employee table and from department table and get some data. So those joins, complex joins, are not supported. But then is it like those developers do not have ability to do that? ऐसा नहीं है. There is a reason behind it. What is the reason? I'll let you know. A MongoDB support joins in a very limited way through use of lookup aggregation operator. So I'll be showing you lookup, but when I do this lookup aggregation operation, I'll not be looking up the data from two different documents, I mean two different sets. It's from the one. The multiple joins नहीं करेंगे because इसकी ऐसी वजह क्या है? Why is it so? This is a conscious decision that the designers of MongoDB has taken. They want to not compromise on performance. So DB's treatment of joins were architectural decision that they have intentionally not provided you this particular service, because to create a join, remember क्या करना होता है to create a join? Anybody quick?
Cartesian table.
Cartesian table. That means all rows from the first table multiplied by all rows from the second table, और फिर उसमें से selection. Now that's complex kind of operation that you do. If one table there are 100 records, another table there are 50 records, so 100 into 50, that's the result. And on that result, you now put a condition and extract relevant data. Now that actually hampers the performance. This was an architectural decision. Designers have intentionally not provided this feature, and jitna diya hai support, that's a limited support that has been intentionally provided because they do not want to compromise on one thing, that is performance. Because both of these features are difficult to provide efficiently in distributed system. So if you really want to have a large data which is distributed servers, and there you would like to perform the join, RDBMs will do that, but it will come at a cost, speed. Here they want it to be working very fast, so this support is not provided only. So without sacrificing speed. So no sacrificing on speed. Speed is critical. That's a key point for MongoDB. Performance is a driving objective for MongoDB. So एक आध feature नहीं रहेगा तो भी चलेगा, but जो है that should work very very fast. Has been shaped for much of the design. So if you think why this has not been provided, उनका philosophy ही अलग है. The purpose, the reasoning on which this new database has been created. Otherwise, it could become another relational database product. पहले ही काफी है ना market में. There is Oracle, there is IBM, there is Microsoft. Everybody has. Microsoft has SQL Server, Oracle has Oracle and MySQL, IBM has DB2. There are PostGIS. कितने हैं market में already है. तो और एक relational database product doesn't make sense. So when speed is critical, this is the database that I will go. Everything that has been कुछ feature दिए हैं नहीं दिए, the motivation behind them is not to compromise on speed. In short, almost every aspect of MongoDB was designed to maintain high performance. So that is the philosophy. That's the basic design approach when it comes to MongoDB. Although MongoDB is powerful, incorporating many features from relational system, it is not intended to do everything that relational database does. So it is not a replacement totally for relational database. Not like everything that relational database can do, I'll do it in MongoDB. No. A lot of features are not required for some applications. So just get rid of them. Focus on performance. Focus on performance. That's the philosophy. But then there are some concerns as well. It's not all everything about good. There are some issues as well. And the concern is security. Okay. And they're addressing to this particular concern in a very good way. But that is still a concern. One thought comes to my mind or anybody's mind if he has to make a choice regarding MongoDB. Due to default security configuration of MongoDB, allowing anyone to have full access database, data from tens and thousands of MongoDB installations have been stolen. Now, is MongoDB only responsible for that? Not really, but the security configuration, if you do not take precaution while you do that configuration, anybody can have an access to the data. That is quite difficult with a relational database. Anybody having an access data becomes difficult. But with MongoDB, it's very easily to breach unless you have not done the configuration very well. So it's a problem of both the side. It is you not having done the configuration properly, and second is like on its own the database is not taking care of security. MongoDB is not taking care of security. Okay, so there is a lot of risk, and there are several incidences where ransomware attacks have happened because of this issue. Further, MongoDB servers have been held for ransom a lot of times because if you do not configure it properly, and that's what we do, we normally install and we start using it. In our course also we'll just install and use it. because in the production environment, when you are using it for large corporation, for your client, where data is sensitive, it is critical, their security is a major concern. So you require an expert who can do that configuration very, very correctly. With Oracle and other things, it just happens seamlessly. Okay, with very less knowledge also you can have very high security installed in Oracle. That doesn't happen in MongoDB. You have to do that configuration in a very correct way. And if you don't do it properly, anybody can have access to that. Security breach can happen very easily in MongoDB. So that's one security concern. Should we blame only MongoDB for it? No. You can blame MongoDB for not doing on its own. That's what you can do. But if you do the configuration properly, then it is secure. But then if you fail to do that configuration properly, if you're not aware of it, and you don't take a paid subscription for them, they are not going to help you. So unless you have an expertise or you take support from them, there is always a risk of a data breach that may happen with MongoDB. But then if you use it properly, it works fine. There is high security that is available, and proof of that is here. These companies like Bosch, Cisco, Pfizer, the Code Academy, the Coinbase, the eBay, Foursquare, so much of data being generated every day. HSBC, banks, IBM themselves, okay, Uber that you are aware of, okay, and the customs department from US, many of them have already switched to MongoDB, So, or they use MongoDB for some purposes. So there are prominent users which are there, but then they have all ensured that it has been configured also properly. The security configuration has been done properly. If you do not do the configuration properly, there is always a security breach risk that you may have. So that was a brief about introduction to MongoDB. I hope you understood the entire philosophy of MongoDB, what we can expect out of MongoDB, how it is different than the relational databases. If you have any questions, please ask. If you understood, give me a feedback. Yes or no पे टिक कीजिएगा जल्दी से. समझ में आया नहीं आया? This was the introduction. Now we begin a journey with this concept of a document. परेशान कर रहा है. कितनी बार डिस्कस किया? हाँ, some new learnings that we had today. What are the new learnings? Can somebody quickly recap some new terms, terminologies that we understood? Important things. Words.
Scale-out, cluster, replica set.
Okay, clusters we understood. Okay.
Scaling.
And scaling का concept. And this scaling is not just in MongoDB, it's everywhere. In Oracle also we did not discuss scaling. Horizontal और vertical scaling में क्या difference था?
Vertical is like CPU बढ़ाना और horizontal is like
सिर्फ CPU बढ़ाना, processing.
CPU and RAM.
CPU and RAM.
हाँ.
Because RAM will give you more. RAM
Cache memory.
Cache.
memory.
You'll have more cache, and you all know about advantage of cache. Yeah? So faster access will happen, and processing power ज़्यादा है तो well. But there is always a cap. How much more RAM you can have in one PC? How much more processors you can have in one machine? There's always a limit. तो जब limit आ जाएगा तो क्या करोगे?
cluster बनाएंगे, divide करेंगे.
नहीं. When the limit of the machine is achieved, यानी you cannot add any more RAM in the machine. Then what will you do?
Increase number of
different split करेंगे ना data.
डेटा की बात नहीं है, मैं कह रहा हूँ प्रोसेसर ज़्यादा इंस्टॉल नहीं कर पा रहे, रैम के लिमिट तक आ गए. यू कैन नॉट ऐड एनी मोर रैम इन द मशीन. देन व्हाट विल इन द सर्वर?
Add a new server.
Add a new server. So when you add a new server, क्या किया आपने?
CPU and RAM.
Horizontal
directly
scaling.
shift.
नहीं. When you add a new server, what has happened is horizontal scaling.
Horizontal.
उसी मशीन को आपने अपग्रेड किया, that is vertical scaling. You add a similar machines or additional machines, and those machines may not be of the same power. Amazon is doing a great work. Google is doing a great work. They do not have all servers of the same capacity. Even tiny small machines are also adding to their processing power and adding to their capacity to hold the data. So clusters and this horizontal scaling, and MongoDB was designed for this particular purpose. Performance and scaling. It was designed to be scaled up. So architecture is so very simple. It can very easily take care. And you as a developer do not have to worry about once that configuration settings are there, it will correctly route your request to the right machine जहाँ आपका database located है. It works seamlessly. Very nice. And there is something called as a replica set. What was that?
Sir,
एक तो shared data था
duplication
और
होगा, shared.
हाँ
Sir, redundancy और availability increase करने के लिए जैसे disaster.
क्या था? मैं replica set क्या था? Basic idea क्या है replica set का?
Backup.
Copies.
No, it's
Copies
copies.
of the data.
It's not just a backup, it's real time copy. Backup क्या होता है? आज मैंने काम किया, उसकी एक बाद में कॉपी बनाई. ये रियल टाइम है, अभी काम करते समय दिस मशीन फेल्स, रियल टाइम उसका डेटा आपके पास दूसरी कॉपी रहेगी, एंड यू कैन स्टार्ट वर्किंग ऑन दैट अनदर कॉपी दैट इज रेप्लिका सेट. एंड व्हाट इज शेयर डेटा?
Distributed data.
Distributed data. So the terms आपको मालूम होने चाहिए. Now we are going on to this area. Things you should all be familiar with these concepts, because this is the very philosophy based on which MongoDB has now been created for you. So that was a brief and document we understood. We understood there is schema less, but keep in mind there will never be a scenario where there is no schema. There will be a case where schema needs changes, structure needs changes. ऐसा नहीं होगा. ये देखो ना, रियल लाइफ में अगर ऐसा सोचो, मैंने अमन के फूड प्रेफरेंसेस स्टोर किए और अंकित के एकेडमिक डिटेल्स स्टोर कर लिए और ऋषिकेश के पेरेंट्स के डिटेल्स स्टोर किए. अरे इट डजंट मेक एनी सेंस ना. बिजनेस लॉजिक में ये कहाँ काम में आएगा? सो रियली इन द बिजनेस सेंस देयर विल बी सम डेटा विच इज फिक्स्ड, देयर विल बी सम वैल्यूज विच मे बी डिफरेंट. ओके, जैसे हमने बात की थी अनंत के पास फ़ोन है और अमन के पास नहीं है, तो देन सम एट्रीब्यूट्स कैन चेंज हियर एंड देयर. Aman has opted for elective subject. Anand has not opted for elective subject. Aman has opted for 3 elective subject. Anand has opted for 1 elective subject. थोड़ा बहुत changes हो सकता है. It's not like everything changes. But keep in one thing in mind. MongoDB is not a replacement for relational databases. It is not designed to do everything that relational database do. There is no competition between them. They addresses different concern. ये दोनों अलग अलग है. Data size बड़ा हो रहा है तो यहाँ distribute करना आसान चाहिए. Speed is one thing that MongoDB does not compromise on. It will compromise on a feature. ये feature नहीं देंगे because that feature will take more time. But they will not compromise on one thing, that is performance, speed. So MongoDB is designed for performance. So let's begin our journey with MongoDB. This was a brief introduction. Tomorrow morning we meet. अब ये schedule fixed है सारे batches क्या? We will be meeting tomorrow. Third day कौन सा? I'll just see and I'll post to you. So 3 days a week we'll have a session and we'll very quickly cover up this concept of MongoDB. This will be क्वाइट अ डीप. सिर्फ सर्वर साइड कॉन्फ़िगरेशन वगैरह छोड़ोगे तो MongoDB को कैसे यूज़ करना है. वन मोर चॉइस दैट आई हैड टू मेक व्हेन आई गिव एग्जांपल ऑफ इंटीग्रेशन विद लैंग्वेजेस. कौन सा लैंग्वेज सिलेक्ट करें? C++, जावा, पाइथन. सो आई हैव टू क्रिएट एग्जांपल्स फॉर दैट पर्टिकुलर लैंग्वेज एज वेल. अदरवाइज जावास्क्रिप्ट में तो है ही, हम लोग बेसिक काम करने वाले. शेल में काम करेंगे तो इट्स ऑल जावास्क्रिप्ट. बट व्हेन आई गो आउट ऑफ द शेल आई हैव टू शो यू इंटीग्रेशन विद सम लैंग्वेज. तो विच लैंग्वेज वुड यू सिलेक्ट? क्लिक ऑन येस फॉर जावा, click on no for Python and click on go slow for C++. या कल पोल ही लेता हूँ मैं बिकॉज दिस वुड बी डिफिकल्ट फॉर मी. C++ के लिए कोई नहीं है, पाइथन जावा इक्वल है. ओके ओके, कल एक पोल लेते हैं एंड दैट पोल विल डिसाइड, बिकॉज ये बाद में आएगा बट आई नीड टू क्रिएट दोज एग्जाम्पल्स फॉर यू बिकॉज आई हैव द एग्जाम्पल्स इन पाइथन. तो पाइथन के अलावा कुछ चाहिए तो आई हैव टू क्रिएट दोज थिंग्स and it's easy. That's it will be a learning for me also because any language we can integrate with MongoDB. Okay, with that we stop for today. Thank you all for attending the session. जाने के पहले एक बार और फीडबैक दीजिएगा मुझे. Did you understand, like the session, whatever it is, give me a feedback. Any queries if you have you can ask. अंकित, दीपक, कंजूसी मत कीजिए फीडबैक देने में. अनंत, okay. Thank you all. See you tomorrow, same time. And we begin our journey with MongoDB tomorrow. Okay, I am just thinking कल क्या topic लूँ. Either I'll take installation or I'll explain the concept of document. Either of the case. Okay. Thank you all for attending the session. Love you all. Good day. Bye bye. Take care.